think I've invited everyone. I shall leave that there, and then we can always we can do pop-out chat, and then we can always just minimize that so that I have chat working. Minimize that, and then I can do this to leave that there, and then I can probably bring this one out so that this one is minimized, and then I can bring this one on this side. Okay people, so here's the thing. Let me say, and we are live. I don't know how long today's session is going to be. It might be shorter or longer than the normal sessions. And we are live. It might be shorter or longer than the normal sessions. However, the thing we need to do is to find a way of making our application work. I'm just making sure there's everyone's okay, everyone's situation nice. I have the charts, and I have Discord over there and everything. Okay, cool. So let's think about this. So we have this audio application on our NRF 52840 dongle. However, let's do this. Let's just quickly come back here and then go here, and then we can do git stash. Okay, git stash -m control R and tract. Okay, good. Yeah, you don't know what that is, so it's fine. Git stash. Let's see, what is it? I don't actually have anything. Git status. Git stash -m periodic damped git stash list. Okay, go. Let's quickly do this. Let's quickly build this application. I can always just go up. Let's build this application, and then we can look at what is going wrong. And then after we see what is going wrong, we can sort of start breaking down what we need to do. I'm not so sure what we need to do. All I know is I have some starvation happening, and then I have some syncing issues, and because of that my data isn't really right. This session might just be me explaining the problem, and then we stop there and we'll come revisit it later. It could be that, or it could be that we dig into the problem and see. Especially if you guys are involved. If you guys are involved, and or if you are involved, not you guys. You might not be a guy, and that's not nice to call you a guy. So especially with your involvement, I might be able to find a fix for this, but this is generally some actual breaking stuff. Okay, cool. So that's that. We built that, and then after we built it, we need to package it into pack.zip. Let's do that. Let's package it into a pack.zip. And then after we do that, I'm gonna do this once per stream always. I'm gonna put this device into bootloader mode. See, it's a red. The device is in bootloader mode. And then after we do that, I'm going to deploy the application to the device. The device is obviously on dev tty ACM0 should. Okay, cool. So let's start a log here and see what happens here. Why are you doing it like that? Why are you doing it like that? Somewhere there's a not a terminate. Okay, cool. So look at it. No, that's not how it's supposed to run. That's not how you're supposed to run. Git status. That is the wrong code you're running. Okay. Okay. Ah, I know what happened. I know what happened. We flashed the wrong code. Okay, cool. We did flash the wrong code. Look, we flashed meh.zip. We were supposed to flash pack.zip. Oh, the other code was me. Was my current attempt at fixing it. Let's look. Okay, cool. Yeah, that's running. Let's go back here and then let's start our logs and then let's see what's happening. Okay, cool. So look, we're getting the first sample. We're getting another sample. But as we go on, what happens is our thread starts running out of buffer space. And as our thread runs out of buffer space, we can now basically no longer, how do I say this? Our thread just dies. The good thing is our app is resilient enough that if we did a different functionality, if we went to the Bluetooth thing, so remember this is a Bluetooth application, this is a BLE application, and you can see here there's temp and light. If we go into the Bluetooth application and we do something like read the temperature, we should get a log that says temperature was read. Reading temperature from reading temperature. So yeah, temp was read by central. See there, temp was read by central. So basically, the central device read the read the peripheral device stuff. This is quite cool because that means our app works, but it runs into a place where it basically ends up. It basically ends up running out of buffer space, and the reason for this is because we're using what do we say? We're using very what would I call it? We're using a very naive periodic capture thing. I2S or I squared S is a continuous, in Zephyr, I squared S is a continuous stream. Once you start it, it's just dumping packets. And I think one of the things that we're facing is that as we are doing this, basically what keeps happening is we keep running into this place where we end up running out of space, because basically we end up doing this thing where we are filling a buffer. Yes, we are emptying the buffer, but if at all we try to, how do I say this? How do I make it so that it's obvious? If at all we try to we're using this buffer and it's filling up, we're not freeing this buffer enough so that it's available for the next thing, and that's actually our big issue. Ideally, after we've consumed the thing, we can do memslab free, and we can free this mem block memslab, and then in that mem slab free this mem block. So this pointer. Okay. But this ends up introducing, how do I say this? This ends up introducing a different issue. Because basically what happens is we end up trying to clean the, let's run it. So we end up trying to, I'm trying to look at the comments on Discord to see if someone has found something. Sorry. So we end up, basically what happens is we end up trying to read the memory before we have it available. Let's see what happens. So let's do that. Let's save that, and then we'll do a git diff so we know what we are actually doing. Okay, cool. Clear. So if we do this and then we go West build. Sorry, it's gonna take a minute. If we do this and then we get West build, the app will crash. We won't even get logs. And the app crashes because the thread, if we're going to main, the thread is defined up here and then it starts up there before we even get around to, and this thread stack size is wrong anyways. So let's do something like 16. Yeah, 16 KB in bytes. What is that? 16.8? 16 what? 16 KB in bits. No. How many bytes in 16 KB? I'm not so sure. No. Is it a word? No. Basically, I want it to be something like 16,000. Yeah, 1 KB. Why? Okay. I want this 16. I want this 16,000, but I want this one 16384. Copy. Google's like, I don't understand. So Control C. Let's do that. Let's save that. Remember, we're running something, and then let's package this thing. Yeah, let's package it into pack, and then I'll put the thing into bootloader mode, and then let's flash this. Let's flash it. So now here you'll start noticing the issues, because the issue here becomes that our thread is started. Look, if I do that, it's gonna crash out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's basically, it's not doing anything. And I think the reason for this is because our thread is missynced. I think our thread is missynced, and it's starting before it should start. Number one, it's starting before it needs, so it's kind of ending up hanging. And then also so if I go, let me see. Yeah, you see, we define a global thread, and then by the time it started already by the time we go. So perhaps let's do this thread so that it's inside, it's after the initialization of audio. Okay, So I think what the whole thing we need to do is k thread stack, and then here it's going to be audio stack, and then in here it's going to be 16384. I think that's okay. And then I want to move this one. Let's move this one into X. Oh, this is a macro, it needs an end. And then let's move this one to below servicing this. And then and then in k thread define, instead of k thread define, let's do k thread define, k thread create, I think, yeah. And then we can do that id, it's fine, that's but we need to pass in a stack first, and then we call it an audio stack. I think it's an audio stack, and then we should do that. And then if I recall correctly, this should be a k msec, because this is a timeout msec. Yeah, also I did manage to get my thing running. Audio thread ID, and temp thread. Yeah, so we need a struct that we pass into here. So we need a k thread. I think it's a struct k thread or something. It should be struct k. It should be something like k thread. K thread is a struct. K thread, and then I think audio thread data. So let's call it that. And then instead here, let's pass data. And rather than pass the whole thing, we should pass the and of the data itself. And then audio stack. I think here this should not be that, and that should give us a clean one. That should make it work. So let's build that. Let's see what that does. Okay, any questions so far? None at all. Let's see. No questions so far. So that's okay. This is fine. This actually works, because then we're going to finish initialization, and hopefully then we can start our thread, and that might change something. Any questions? Any questions from the people reading this? Any questions? Okay. If you can see somewhere I'm messing up, please save me, because this is going to be, so we've built that. Let's pack it into pack.zip, and then let's set this thing into bootloader mode, and then deploy pack.zip. And then as we deploy pack.zip, I'm going to look questions. Discord, no one. It's actually choppers, no one is here today, but that's fine. That's amazingly fine. Sometimes you gotta do stuff. Yes. So our thread crashed. And I have a feeling it's because here, when we stop, you see here. So let's go into audio service. Audio service. You see here, once we stop, this doesn't mean, this stop capture doesn't mean that let's see, nothing. Okay. This stop capture rarely means that, it doesn't mean DMA has stopped filling the blocks. You see? And let's add some code here. Let's add some memslab freeze here. So while one, okay, and then while one, and then we just need to do the same thing we did before in the thing before. Void memblock. Can I just use them once? Can I make them global in this function, and then we'll see if something later causes them to break. Besides, they should be mutually exclusive by where they are. So the thing I'm learning about I squared S is that I squared S is a continuous stream. So even if we did actually stop the stream here, that doesn't mean that the DMA transfers into the memory slab that we had built before had stopped. So after we do this, let's rect equals to I2S read, and then in here we need to take the I2S device, and then in here we need to read into memblock. I think memblock, yeah, memblock. And then in here we need to use a size which is defined somewhere up there. It's a uint32. uint32. That's supposed to be closed, and then that, and then let's get in here, and then let's drain. Basically what we're doing here is we're draining the, it's the same thing we're doing up here. It's the same thing we're doing here, this. But ideally what we do here, here we will do, let's put a log here so that we can actually know what it is. Process RMS of block data. Okay, see, that way we can do that and know. And then in here we are going to be doing the same thing, but instead of here we're going to do log 1. We won't even read it. We're just gonna do empty drain remaining items in buffer. Okay, look at that. So that's what we're gonna do there. And then the thing we're going to do here is kmemslab free, and then we will free that memslab of this memblock. What? But it is, we are reusing that memblock over and over again. I don't know if that's gonna be the problem. So someone who knows about mem slabs and blocks, please let me know. Else, and then let's check if we know. So you can, this, I'm using this I2S read. I2S read Zephyr. I2S read. So we're looking at I2S interface, and then we're looking at the read function. The read function can, interface is not ready or in error state, return without waiting and stuff. So basically, there are no more data blocks in the queue. That's the one we want. EIO. Else if ret equals to minus EIO, error IO, and here we will do log warn all logs drained. We can safely sleep for next time. Okay, and then there's that, and then let's close that out, and then let's close that out, and then let's get out of the while, and then after here, who are you? That's just you from earlier. And then after here, let's now sleep the thread for 2 seconds, and then once we sleep this thread for 2 seconds, we can come back later to here. Let us see. What did we add? So we put that as a thing, as a global, and we can use it in here, and then we can also use it down here, and then in main we just did that. Okay, cool. Let's go build this. Any more questions? Any questions? I'm gonna check for questions. No questions so far. Yeah. Oof. Oh, that's an interesting way of doing it, so that you can do. Yeah, it's still building, so too busy building to know what is happening. I have a small chat window and a small Discord window. Samples unused. Yeah, it's fine. Process block data. Item 1 is D, yeah, and then sample flow. It's fine. That should get rid of the error, but we'll deal with the error later. We'll deal with the warning later. Sure. So we've done that. We want to pack this into pack.zip. Remember, our current iteration just stops. Okay, so let's see if that changes anything about our current iteration. I'm going to restart the app, put the app in bootloader mode, or rather the bod in bootloader mode. And then I'm gonna pack the app into it. Let's see. So app is packed. Let's run logging, and we do have a problem. Because this is only done once. We never do it again. I'll show you that again. 1, 2, 3 should go on now. Yeah. So yeah, process RMS block, capture cycle complete, and then we never even actually drained the stuff. So even the first time, we still don't drain it. Process RMS of that, and then somehow we are crushing. The app keeps on running as normal. That's a good thing. We've now, this is an advancement on the code we had previously, because right now it's I'm connecting to it, and then I will do a read. Okay, I'll do a read, and then we should see something was read from central. Temp was read from central. BLE module. That's fine. So BLE module temp was read from central. So the thing that is happening is it appears that we come and we do that and we do that, and then we never even actually get into here. Must we? But we never even failed to read. And then we drop this. We do drop it. We trigger a drop. But then okay, cool. Yeah, sure. X. Let's try that. I could be suffering corruption. FP. I'll fix this just now. Okay. No. And then I save that, and then I can just do a clang. Give me a clang. Give me a clang format command. That's fine. So that I can see my code in a nice way. This is progress, for sure. This is progress. This is progress. This is a lot of progress, because we're not ending up with a dead audio peripheral. That's kind of diff. That's kind of good in the first place. So we're not ending up with a dead audio peripheral. I feel like I need to check for not ready again somewhere. I'll see just now. Let's look at this change. And then let's build this. And then while we're building this, let's go back here and look at this. You see, waiting period timed out. So basically, we can get an again when we try and read the thing. But that would still trigger this branch. This branch would still be available for that. And it's not. So we never get there. I mean, yeah, we never get there really. And it's not like we stop the service or anything. If we look at the PR from yesterday, or rather the changes I've done this morning. Yeah, this doesn't really change anything. So I wanted to do this thing where we check for an again and see if that will cause something to show up, but it never actually shows up. So that's a fast stop. Okay, cool. Let me put this thing in bootloader mode. Put it in bootloader mode, and then what did we add? We made the things not globals. Send them in there. Let's turn this up and let's log it. Let us do the application. Let us load the app and see. So let's start that and see screen. It's a good sign. Updating temp, capture cycle complete. Yeah, that's fine. What? Okay, cool. So, oh wow, the embedded is hard. Okay, cool. So let's look at this. 1, 2, 3. I want to get capture cycle complete all the way to here. Copy. So let's. Where do I put this? Do I have notes? Do I have notes? I have a text editor of some sort. I do have a text editor. It's called Vim. So let's look at it. Sensor module, reading temp, audio module, capture cycle complete, process log data item 1, 0. UDC, that's okay, that's fine. Capture cycle complete. It's as though we never drop into this part. It's as though we never get into here. Let's do else log dot warn log dot error. This is what is happening. We never get here, and because we never get here, that actually might be the issue. I think so. Ret. Let's see what that gives us. Let's see what that gives us, and let's build that. Let's build. Any questions so far? Any questions so far? Today we're doing debugging. There's a bat outside my window. And we're logging capture cycle complete here. Yeah, let's. I want to log this here. Was I building already? You are building already. I won't stop. I won't stop and start again. See. Trying to see if I have questions on WhatsApp as well. No questions. No questions. No questions so far. Okay, so that's built. So let's pack it into a pack.zip. Put this guy in bootloader mode. And now let's send an app to that guy in bootloader mode. I christened my microcontroller a guy so that it's because it was born. They identify as a guy. Okay, cool. So let's see what happens here. 1, 2, 3. Are you gonna give me something? This is what is happening. Yes. We have an error. So -11. That is. If I'm not wrong, that is going to be error IO. It's either E again. -11 Zephyr error. E again. So E again means it's busy. E again means it's busy. E again means it's busy, no? E again means it's busy. Waiting period timed out. What's the read? How do I essentially ignore it? How do I essentially ignore it? How do I essentially ignore it? How do I essentially ignore E again? Because I want to, if I do encounter it, I should just continue. KMSEC1, sleep KMSEC1, and then continue. Let's start it like that. Let's do that. So let's handle that. If red is equals so else if. So we don't need that, but let's keep it in because we don't know. So let's go like if red is equals to minus E again. Okay. And then we go in here and then we do that and then we do that else if. And then what we need to do here is we go, I don't want to break out, I don't want to go somewhere else. I want to go like, so was busy, wait a bit, K sleep, K MSEC 1. Can we do that? And then that's it. And we never actually break out of this thing. You see? Do you see another thing? We never actually break out of this while loop. And I have a feeling we need to break out of this while loop at after everything has been cleared. So this is break, yeah. So just, does that mean we'll stay in there? We will stay in there. So if we get anything before, we'll just stay there, and then we'll keep running the same loop until we're there. So let's do that. Let's rerun that again. Let's build that. Let's build. Let me look at YouTube. Oh. Let's see if YouTube is actually working. Yeah, that's it. And we are live. YouTube is live. Oh, what's happening now? Put it in here. Yeah. And expand that. And how many views? 15. Average view. Okay. Cool. YouTube's running. Cool. We were building something. I don't break out of the while loop. Basically, I should. Let's build that. Let's see that. By the way, calculating the RMS of the signal is going to be quite simple because we're going to end up using the ARM compute library, which has a function that goes like basically calculate ARM, we need to make the mean, and then we need to make the square root of the mean, and then all of that stuff. Square of the mean, the square of the mean to get the variance, and then we need to get the square root of the variance to get the RMS, and then we have the thing we need. But before we do that, we need to make sure we're getting the actual data we need to get. It's going to be a one function call. I think it's more exciting to get the data than to try and do that. So let's pack that. I'm gonna put this guy in bootloader mode, and then let's deploy that. and then we should have some sort of, we'll see, we shall see. We shall see. So I don't want that thread crashing. That's good. This is good. RMS 1. Yeah. 2. 2. 2. Oh, the thread still crashes. The thread still crashes. Why? Why does the thread crash? Let's stop the other threads and see if we stop the other threads and see if we actually get anything better. And stop you, stop you, stop you. Maybe not you, because you might make some things in the app crash as well. So let's go here, let's build it again. So somehow we're not invalidating our memslab good enough, and that is causing our app to break. But we have all the somehow in here we're messing up. If it was E again, sleep a bit and then try. That's fine. Just sleep a bit, and then if you want to do a continue. We need to do a continue there. Would that change anything? And then after it is drained like that, not so sure. Because the thing is, does anyone have any suggestions? Let's see. Does anyone have any suggestions of how to deal with this? I think I can make it dump. I think I can make it dump some stuff. Yeah, thank you. That's a good one. Dump the thread. Dump the thread. Ooh, I see what you're saying. So basically, dump the thread. Dump the thread. Okay, so let's go into kconfig such kconfig. I know I was building something and I'll get back to it just now. Oh, okay, let's pack it. What change did we do now? We stopped the other threads. Oh no, that's not gonna work. Packet. Put this one in bootloader mode. Push this guy in, and then, but basically I'm gonna have nice. We don't have to stop the app, so we'll just get all the threads and then go here and build that 1, 2, 3, 4. Cool. That's it. Just stops. Just stops. I think we want to do something like a fault. have this applied somewhere in our code. Cut build Zephyr .config grep fault. Fault dump 2. Yeah. Yeah. Catch thread fails Zephyr. I don't know that I want to check that yet because I don't think Zephyr dump faults. It is enabled, so core dump. Yeah, no, we don't have a fatal error. We don't have a fatal error. That's the problem. We don't have a fatal error. It's just our thread that is dying, and then our thread dies, and then we never get anything else. So there's that. Yeah, basically just stops. Audio process that, and then just stops. And then just stops. Never proceeds. So we do that. We start. We go through here, we say that sample, we're going to process it, and then we free this mem slab. Free this mem slab. That's the line where we're crushing it, so let's see. Okay. I think I'm probably gonna rename. I think this is a debugging stream, man. K-mem slab free. Is it that I don't know how to use K-mem slabs? K-mem slab free. K-mem slab free. Memory slabs. You know what would be funny? You know what would be really funny is oh my God. You know what would be really funny is like if we needed to allocate the slab before we used it, and then we also like, and we've lost like 2 days of debugging to this. That would be quite funny. Mem slab. Mem block. And then K, no wait. I need to do error checking on that. My code is gonna be 900 lines of like checking errors. Okay, cool. So let's run this version fast without the memslab, and then we'll come back and we see. I don't know. It would be so funny if that's actually the problem. Okay, let's pack it in. No, packet. Oh, damn yeah. Let's just build it. Build a new version. I doubt that I need to allocate the memslab before I use it. I do wonder if that's what's breaking. Yeah. My cat's on the floor. I do wonder if that's what's breaking. It's been an hour of streaming. It's been an hour of debugging. I wonder if I should go on. I mean, if you're here for debugging, it's cool. It's been an hour of debugging. I might stop just now, but let's give it a couple of bashes, and then we'll go back to this. Is the issue that I need to allocate the memslab before? I thought it was dynamically allocated, but that might be. Oh, that sounds sus. That sounds suspect. Let's pack it. Okay, cool. I put this guy in bootloader mode. Cool. It would be so funny. It would be so funny if that was the issue we're facing. But it would be cool because it's actually real development. That's real development when one line in a folder somewhere just makes your whole app break. And I'm talking about DTS. That's a good sign. Because now but it's also not a good sign because that's garbage now. And nothing else is failing. Okay, I have a feeling that our issue is how we're using this memslab. My sample is based upon the studies I did on this Zephyr samples I2S. Yeah, this one. So this is the basis of my example. The thing I'm building right now is based on studies I've done on this, which is the I2S codec sample in Zephyr. And I can see how they do memslab. Okay, memslab defines static. Maybe that's gonna be a difference. Okay, memslab defines static, and then memslab, and then memslab. No, this is actually the echo one, so I can actually go back. My sample, I use the echo sample, so let's look at the echo sample. So it's main. And then control F, memslab. Yeah. Okay, memslab defines static. I don't know if I use a static one. Okay, cool. But that's fine for now. Okay, memslab alloc. That's actually my issue. And that has been the issue all this time. I know how they dealloc later because let's just Are you telling me I need to allocate it down there? Because I freed it before? Because I'm hitting that KMM slab free? Let's go. Let's see. Let's see if that fixes our thing as we do. Why? And then let's go here before we do that. Okay. I swear this is the issue, but we don't know. It's gonna be something. What we're going through right now is the discovery of starvation in our app, inconsistent memory handling, and inconsistent API knowledge. I don't know that API well enough to be able to use it in a very judicious way. And my memory is all over the place. Described by this garbage. This is garbage. This is garbage. It's a 24-bit. It's a 32-bit integer. It's not gonna be. It's a 32-bit integer. It's not gonna be that. So, cool. I think so. That's garbage. So let's see. And I have a feeling we're crushing. I mean, we're gonna make the code a lot longer, but we need to do if this allocs and this frees are, okay, memslab free API reference API. Okay, memslab free. What do you return? You could return. Okay, memslab free. Doesn't return. It's a void. Okay, memslab alloc. You're the one we need to check. Okay, we can check those two after we do this. Let's packet. And that's. I am so embarrassed. We were using an allocated memory because I thought the memory was allocated. No, that doesn't change anything. I do want to GG. I do want to go here, memslab define. I know this is in the global context, but I have a feeling I'll just put it here. So that it's actually defined way before. Let's look at the other code. Where do they define the memslab? In main? Okay, memslab defines static in main. Once, every time the thread is called. Let's see. Let's look at audio service.h. Let's see. I'm wondering if this is the issue. But it's in a global context, and this is running because this module register is running because we get that, and I don't see why that's gonna fix it. What did we change now? We changed nothing. We programmed the device. We haven't changed anything. Okay, unless anyone has any suggestions on how to deal with this, I think I need to go and study how the memory slabs are used. Because somehow this is garbage, somehow this is garbage, this is garbage. So if we just do that, and let's run this again. So yeah. Now that's even worse because it's the same thing. It's a microphone. You should pick up different data all the time. So that's not actually the way it should do. So I need to go and study how the memory slabs are used because we have some inconsistencies in how we are handling the memory slab, and I think that's where our data is going wrong. So thank you so much for joining me on this debug session today. It's been an awesome one. I'm learning a lot, but I'm also quite confused because I don't know why the application isn't working. But this is something we can figure out quite quickly and as we go along. And anyways, it's always the things you learn when you're stuck that actually matter. So unless we have any questions about today, thank you so much for coming. It's been an awesome session. Check you guys next time. I don't know what I'll be doing tomorrow. I would have said I'd hope to be doing DSP stuff, but that's not what's happening. That's not what's happening. We're still going to be debugging this. Okay. Cheers, people. Thank you so much for coming today. I shall see you again. Yeah, for sure.